There are many moons in the solar system, but none like ours. It exerts an extraordinary influence on planet Earth, keeping our world in balance. This is the story of how the moon has sculpted our planet and shaped its evolution. Without the moon, would we even be here? We take the moon for granted, up there in the night sky, 250,000 miles away. But what would happen if the moon was in a different position? Closer or further away? Would Earth be a world transformed? The moon is just a rock in the sky, but it has the power to move enormous amounts of water across our planet. And every day it puts on a show at Loch Etive on the west coast of Scotland. At high tide, up to 66 million tons of seawater is sucked into the loch from the Atlantic Ocean. And at low tide, it pours out again. The head of the loch is like a bottleneck. The water is funneled through a narrow channel with a phenomenal brute force. These are the Falls of Laura. Kayakers come from across the world to take on the challenge of these waters. And for an hour or two, this becomes one of the wildest, wettest rides in the world. This is what the power of the moon looks like close up. The tides are the most striking evidence of Earth's intimate relationship with the moon. But it's shaped our human experience in many other ways. It became a place we dreamed of visiting. And 40 years ago, 12 men did just that, transforming the way we felt about our nearest neighbour. It was 1969, and our love affair with the moon was about to take off. This was the age of Apollo. Man was going to the moon for the very first time. The images of Neil Armstrong's first steps were seared across every schoolchild's mind. And over the next 4 years, 5 more missions followed in his footsteps. But since then, hardly anyone's been talking about the moon. It used to be the new frontier, the future. Now, for most people, it just seems a bit quaint. Somewhere we got excited about a few years ago, but then slipped off the radar. But should we still be mad about the moon? The more we know about our lunar neighbour, the more fascinating it becomes.
It's just incredible that the moon, which is nearly 250,000 miles away from us, is having an effect on Earth. And the most dramatic effect is the tide.
And these tides are caused by gravity. Gravity is a great universal force. It keeps us firmly in our place on Earth and keeps the moon in orbit around us. But while the Earth is pulling on the moon is also pulling on the Earth, tugging at our seas.
Gravity is a very powerful force, but you can't see it. It's a force of attraction. Another force of attraction which works in a very similar way is magnetism. I've got a block of metal here. It's on some scales, and it weighs 2 pounds and 14 ounces. And that's Earth's gravity which gives it that weight. And I can put this very strong magnet above it, and there's a magnetic force of attraction pulling at the block, making it weigh effectively less. And the numbers are dropping away on the dial. Gravitational attraction works in a very similar way.
The gravitational force of the moon causes the water in the oceans to bulge. And as the Earth spins, this bulging produces high and low tides. The size of the tides depends on the distance between the Earth and the moon. If the moon was just a little closer, the tidal bulge would grow. Low tides would be lower. High tides everywhere would be higher. And any low-lying coastline would be flooded. But what if the moon was much closer than it is today? Another rush hour in London. But this evening, as the sun sets, there's a magnificent sight. A huge moon rises, 20 times closer to Earth than normal. This supersized moon exerts a supersized gravitational pull on the Earth. And it's creating a mighty tidal bulge. The waters pour across the British Isles. London is flooded. Hours later, the same tidal bulge hits the east coast of America, and the story is the same. New York is inundated, a city submerged. And it's all the work of the moon. This may seem like the plot of a disaster movie, but take a look into the distant past. 4.5 billion years ago, when the solar system was still very young, the Earth had no moon. It orbited the sun alone, bombarded by comets and asteroids, like a game of cosmic pinball. Today, Earth's surface shows no scars from this ancient onslaught. But to get a sense of the damage that was done, Dr. Ed Belbruno has come to the Arizona desert, to a mile-wide hole in the ground.
The crater we see here, which was hit by an object 150 feet across, would have been child's play by comparison to what happened at that time. Instead of one object hitting, there were 1,000 of them, or 1,000,000 of them. It would be worse than a nuclear war.
And some of these trillions of rocks had collected together to create something far more threatening. It was a protoplanet, Theia, and it was on a collision course with Earth.
So you would see a very bright object up there, like a star, and day by day this would get larger and larger until finally the entire sky would be a gigantic planet looming in on you.
Theia hit the young Earth with a glancing blow. Its core fused with the core of the Earth, sending huge amounts of liquid rock into orbit.
If you could stand there and see this, you'd see the sky would be lit up. It would be lit up with an orangey glow, which would be all this magma-like hot material all over the sky. And because it's in a fluid state, it's very easy for it to coalesce and form a spherical object, which is going to be the moon.
Imagine the scene. The first moonrise over the early Earth. Our planet had a neighbor. A molten moon in orbit, just 14,000 miles away. This made Earth a very different type of planet. The collision with Theia pulverized the young Earth. It was turned inside out. Metals like iron were released from the planet's core and reset Earth's basic chemistry. Gases like methane, carbon monoxide, and hydrogen seeped into Earth's atmosphere. And Earth was transformed. These gases were the stuff of life. In the 1950s, American chemist Dr. Stanley Miller carried out a classic experiment. He took a cocktail of these gases and simulated conditions on the early Earth. What emerged was a film of brown slime, but it was full of amino acids, the raw material of proteins. They'd been created from nothing but the gases on the early Earth. The collision that formed the moon had helped set the scene for life to begin. But life didn't start immediately. It took up to 700 million years for the simplest single-cell creatures to emerge. Again, the moon could have played a crucial role. While the Earth was cooling down, water vapor condensed to form oceans. Because of the moon's influence, these oceans were tidal. And according to one of the latest theories about the origin of life, these tides made all the difference. Professor John Sutherland believes that the tidal power of the moon could have kick-started life on Earth. And this is how he thinks it might have happened. Adding chemicals found in the early oceans, then water to his flask. He's recreating the conditions in a tidal pool. The water then evaporates away. As the sun would dry out rock pools at low tide. In this flask, the chemistry of life is stirring. And just as the tide would return and flood the rock pools, so John adds more water to the flask. Now, just add ultraviolet radiation, and the chemicals are transformed by the light that bathed the early Earth.
So what we started off with was some very simple chemicals. We dissolved them in water to mimic the tidal pool. We then evaporated it to mimic the tidal pool evaporating, added some water again. We've now irradiated with ultraviolet. So the conditions are very, very simple.
These simple conditions, just the wetting and drying made possible by the tidal power of the moon, created something remarkable. If this mixture were analysed at molecular level, it would show that two of the building blocks of RNA, ribonucleic acid, had been formed.
And what it's produced now is outwardly very complex molecules produced from very, very simple materials under very, very simple conditions.
RNA, one of the most fundamental ingredients of life, could have first been created by these early tides, orchestrated by the power of the moon.
Tidal zones are chemistry laboratories, prebiotic chemistry laboratories. Each pool will have slightly different conditions, slightly different chemistry taking place. One of those pools will have the chemistry required with these chemicals to give rise to the building blocks for RNA.
And RNA means life. Once the first creatures emerged in the oceans, evolution was in full flow. Ever since that time, the moon has continued to watch over us. And while humans have been on the planet, we felt compelled to stare back. Whenever we look at the moon, we always see the same face. That's because the moon rotates once every 29 days. And that's exactly the same speed that the moon orbits the Earth. So as the moon travels around us, it's always showing us the same craters. We never see the far side, or the so-called dark side of the moon. But lunar missions have revealed that there are many more craters on the far side. Each one is the result of an asteroid impact. An asteroid that could otherwise have crashed into Earth, perhaps even stopping life in its tracks. The moon, which could have helped start life, may also have preserved it. Our guardian angel. "5,000 years ago, the people of the Outer Hebrides believed the moon to be more than just a protective spirit. They shaped these rocks into megaliths and placed them in a great circle. With only simple tools, it was a remarkable feat. All the more so if, as some suggest, our ancestors were building an observatory to mark a rare lunar event. Because of its orbit, every 18.5 years, the moon barely rises above the horizon. It's known as a lunar standstill. The builders of Callaniche seem to have followed the moon's lowering path in the sky and aligned their stones to witness it. The moon sets directly within these stones. To pull this off, they had to align the stones exactly, only able to check their position once every 18.5 years. It seems incredibly complex, so why do it? Across the ancient world, people invested the moon with magical powers. And today, we still believe in the power of the moon. The rhythms of the biological world reveal the moon to be a driving force behind the cycles of life on Earth. Many animals react instinctively to the moon's light. These creatures become more active, more vocal, more fertile. Most remarkable are these tropical corals. Every year they synchronize their reproductive cycles so that on one night they all spawn together. For these corals, that night is triggered by the full moon. Few other creatures on Earth are as sensitive to the comings and goings of the moon. The Sargasso Sea off Bermuda. Marine biologist Dr. Anne Cohen has come to investigate the power of the moon. She's looking for a species of coral known as Diploria strigosa, the brain coral. Every 29 days on a full moon, brain corals grow a new layer of skeleton on top of the old. This growth spurt is triggered by the monthly orbit of the moon. It's like clockwork. And these layers can be used as a lunar calendar.
So I'm looking at the coral that we pulled out of the water today, and if we look really closely under the microscope, we can see the fine ridges. Well, we know that these ridges are built around the lunar cycle. So each ridge represents about a month of growth of the coral. And this particular coral has about 65 ridges. So we can use these monthly bands to age the coral. If there's about 65 bands, we can estimate that the coral has been living for about 5.5 years.
But some corals are even more revealing. They allow us to peer into our distant past. This is a fossil coral from the Devonian era. It's 400 million years old. On this coral, as well as the monthly bands, there are also annual bands laid down each year with the passing of the seasons. There are even daily bands, 1/4 millimeter apart.
So when we count the number of daily bands, what we find is not the 365 daily bands that we'd expect within a year. We find more like 400 bands. And this suggests to us that 400 million years ago, there were 400 days in the year rather than 365. That's an extra 35 days in the year.
Divide the hours in a year by 400 days, and you'll find something extraordinary. In the Devonian era, when this fossil was alive, a day lasted 21 hours and 55 minutes. Something has been slowing down the Earth's spin. The length of any day is simply the time it takes for the Earth to spin around once, to go from one sunrise to the next. If days were shorter in the past, then the Earth must have been spinning faster. If you go back billions of years to when the Earth was still a molten planet, it was spinning so fast that days lasted just 5 hours. But why should the spin of the Earth have changed over time? It's all down to the moon. The early moon was pulling so hard on the Earth, it slowed down the spin of the planet. And it's still doing so. As the Earth spins, the friction between ocean bulge and ocean floor is slowing the Earth's spin, and our days have continued to lengthen. But what about the moon itself? It's been affected by the spin of the Earth, and as the Earth has been slowing down, the moon has been speeding up. When anything in orbit speeds up, something happens to it. Imagine the Earth is at the centre of this roundabout, and that the children are where the moon would be in orbit. As they speed up, they're flung outwards. And that's what's been happening to the moon. As it's been getting faster, it's been spiralling out into a wider and wider orbit, drifting away from us. But is the moon still drifting? Or has it finally stopped? There is a way to find out. This is Apache Point Observatory in New Mexico. It's home to one of America's largest telescopes. It's also one of the last outposts of the Apollo program. Besides having fun on the moon, the Apollo astronauts were running scientific experiments. And on 3 of the missions, they left behind retroreflector units, packed with small mirrors. This one's from Apollo 15. Astronomers have been firing lasers at them ever since, keeping track of just how far away the moon is.
So once we're all centered up on Apollo 15, we're ready to shine the laser.
Dr. Russet McMillan works on the laser ranging program at Apache Point. They fire a laser at the Apollo reflectors on the moon and try to detect the light's reflection. By capturing just a few photons, particles of light, and factoring in the speed of light, it's possible to measure the distance between the Earth and the moon, down to the last millimetre.
We're not quite getting the 1 photon per pulse that we were hoping for. Right now we're getting about 1 photon in 10 pulses, but it's still pretty good.
Once the computer has averaged out all the laser readings, the result is revealed.
As of right now, the distance to the moon is 393,499 kilometers, 257 meters, and 798 millimeters precisely.
Astronomers have been using lasers to measure the moon's distance for 40 years. And what they're finding amongst all those photons is a very clear pattern. The moon, which has been drifting away from us for billions of years, is still drifting at a speed of 3.78 centimetres a year. And does that matter? Well, yes. For one thing, if the moon keeps going, we'll lose a great natural wonder. The moon's 400 times smaller than the sun, but it's also 400 times closer, so they appear to be the same size. And that's what gives us the most mesmerizing of sights: a total eclipse. The moon's disk fits perfectly over the sun. It happens because right now the moon is just the right distance from the Earth. A random but wonderful cosmic coincidence. In the future, as the moon continues drifting away, its disk will be too small to cover the sun. Earth's total eclipses will be lost forever. And then what? As the moon moves away from us, how will life change here on Earth? New York City. The sun went down an hour ago, and the moon is rising. It may look familiar enough, but the moon is smaller than normal in the night sky. That's because it's further away. Not much, an extra 10%, just 24,000 miles. But that makes all the difference. The spin of the Earth has slowed down and days are getting longer. The sun won't rise here for another 20 hours. The entire Western Hemisphere is locked in a very long night, while the Eastern Hemisphere is experiencing a very long day. With the moon 10% further away, the daily cycle of our planet has been transformed. And things get even more extreme. This shift would threaten the very stability of Earth. The moon, which controls our tides and the spin of the Earth, serves another critical function. It keeps us stable.
You imagine if you spin a basketball on your finger, then if you spin it fast enough, it's going to maintain stability. You can leave it up on your finger for a while. But as it starts to slow down, eventually it's going to wobble and fall off the finger. Similar thing happens with the Earth.
When the Earth was spinning very fast, it was very stable. But as it slowed down, it would have lost stability and started to wobble had it not been for the moon. The angle of the Earth's spin is constant only because of the moon's gravitational pull.
If we didn't have a moon right now, the angle would vary chaotically between about 0 and 85 degrees.
Ever since the collision which created the moon, the Earth has been tilted, spinning at 23 degrees. This tilt has played a crucial role in our climate. If the planet was upright, the sun would always be overhead at the equator, never shining on the poles. But because of our 23-degree tilt, the amount of sunlight hitting any point on Earth varies over the course of a year. We have periods that are wetter or drier, warmer or colder. We have seasons. The life cycles of animals and plants across the Earth are driven by the beat of the seasons. A burst of life in spring, the balmy days of summer, migration in autumn, a fight for survival in winter. But the Earth only stays at its 23-degree tilt because of the stabilizing effect of the moon. As the moon drifts further away, the Earth's tilt will shift, and over millions of years could swing from 0 to almost 90 degrees and back. With the Earth almost tipped on its side, for 3 months every year the poles would be exposed to direct, unrelenting sunshine. Pretty quickly, the ice caps would melt. A huge amount of fresh water would flood the world's oceans. Sea levels would rise by around 65 meters. Every coastal city in the world would be gone. And any inland areas that survived would be transformed. Las Vegas is dark and very cold. It's minus 20 degrees Celsius. Because the sun is pointing at Antarctica, Vegas is in the grip of an icy winter. But in spring, the snow melts and the sun rises higher and higher in the sky. In the summer, the sun never sets. In autumn, it's high in the sky, before dropping below the horizon again as the darkness of winter returns. Could we survive? Well, that would depend on what happened to the rest of life on Earth. Dr. Lynn Rothschild is an astrobiologist working for NASA.
Death Valley is the hottest place in North America. And as the moon starts to go away from the Earth, there are going to be periods of time where the Earth tips enough on its axis that parts of the Earth will be much hotter than Death Valley is in the summer. And these same places will be bitterly cold, colder than the Antarctic in the winter. We know of isolated organisms that can live at very low temperatures. I mean, think of penguins and so on. At high temperatures, you start to break down your biomolecules. So, for example, at about 72 degrees centigrade, chlorophyll breaks down, and then beyond that, your cell membranes start to melt, just like butter in a fry pan. Your proteins start to denature, in other words, break down. Your nucleic acids break and they melt, and this is your very genetic material.
Some microorganisms have adapted to live in deep-sea vents and geysers at temperatures over 100 degrees Celsius. But they couldn't thrive in the freezing cold. And that's the problem. If the Earth topples over, the seasonal shifts will be too fast and too extreme for evolution to keep pace.
Once you've evolved to live in these incredible extremes, you really have pretty much committed yourself to one extreme or the other. We don't know any organisms that can be active and thrive at both extremes, certainly not on a yearly basis.
It'll take at least 1 billion years for the moon to drift far enough away for the Earth to tilt like this. So there's a little time to prepare. But this speculation clearly shows how lucky we are that the moon is where it is right now. A tiny shift and life on Earth would be radically different. And what about life beyond Earth? Are we alone, or are there other planets out there similar to Earth, supporting life forms similar to ours? These radio telescopes are scanning the heavens looking for clues. Within our solar system, there are over 100 moons, but they're not like ours. The moons of Jupiter are too small to have any impact on the gas giant. The same is true of the moons of Saturn, Neptune, and Uranus. Only our moon is large enough and close enough to affect us. We dream that one day we'll find other planets with moons like ours, and that on them we'll discover life. But could we ever visit them? Could we ever boldly go out into space? If so, the moon might help us. So far, only 12 people have ever been to the moon.
Basalt is in bag 512. Got it. That's 20 pounds of rock. As you come around there, there's a rock in the near field on this rim.
And they brought back a very precious cargo.
Oh, Tony, it's got some beautiful crystals in it. Good show.
382 kilograms of lunar rock. When geologists analysed these rocks, they learnt a great deal about the moon, even about the history of the solar system. But they didn't find what they were looking for. Any sign of water. The moon, they declared, was bone dry. The moon rocks are stored in a virtual vacuum and can only be accessed from a clean room. NASA curator Dr. Gary Lofgren has the job of keeping the rocks pristine, as if they were still on the lunar surface.
When you look at the rock is incredibly fresh, absolutely pristine looking. I mean, all the crystals are shiny when you look at it and they reflect back at you, and that's what everybody remarks on when they see them. All rocks on Earth, no matter how fresh they are, have some alteration from the water that's in them when they come to the surface as volcanic rocks. On the moon, there just was no evidence of that. So that gave us the idea the moon was very dry, very inert. And we thought that for 40 years.
But now they've changed their minds. Recent probes have analysed some of the moon's darkest craters at the lunar poles. And scientists believe they're packed with ice, frozen water that has come from comets crashing into the moon over billions of years. It's a discovery that could transform space exploration.
It would be possible to actually separate that water into hydrogen and oxygen, and that's what we use for rocket fuel. And so that would give us, we could refuel our rockets and wouldn't have to carry as much fuel to the moon.
Rocket fuel is precious stuff. You need thousands of tons of it to escape Earth's gravity and get into space. But if, in the future, you could fill up with fuel on the moon, that would make all the difference.
Having that amount of water is actually very important for colonizing the moon or for future long-term exploration of the moon. It makes all that possible, where before it would have been very difficult.
Perhaps one day the moon will become a springboard for exploring the solar system. Spaceships will make the short hop from Earth and then refuel here before setting off on the long journeys ahead. But if this seems too futuristic, one man has more immediate plans for the moon. Plans for it to power our planet. For 30 years, space scientist Dr. David Criswell has had a dream to harness the sun's energy and put thousands of solar panels on the moon.
If you look up in the sky and you're looking at a full moon, you're seeing 13,000 terawatts of power. By going to the moon, we can collect that power at the cheapest cost and send it back here to Earth.
In his plan, parts of the moon would be covered with thin solar panels. The electricity would then be relayed back to Earth using microwaves. And you can rely on sunshine, because on the moon it's never cloudy.
The moon is far better than the Earth because it has none of these disturbing influences. You have no water, you have no air, there's no mechanical vibration, so you don't have to build massive facilities like this. These things could be replaced by solar arrays that look like newspapers spread out on the surface.
David believes he can tap enough pure energy to meet global demand many times over. The moon bases would harness vast supplies of solar energy. It would kickstart a new lunar economy, as the moon itself would provide all the raw materials.
When you look at the moon, basically what you see is dust. You can make it into fiberglass, you can make it into containers, you can make it into rods and tubes and all of that sort of stuff. So it's totally sustainable.
Now this plan doesn't come cheap. It would cost at least $500 billion. However, that's less than the oil industry currently spends every 2 years getting oil and gas out of the ground. And David has a theory about why we haven't already built a solar-powered base. A home from home on the moon.
This is not happening because we did not stay on the moon during the 70s. If we'd stayed on the moon, the United States, and focused on how to use the materials that are there, we could have started this project in 1980. We've got to go back to the moon. Somehow we've lost the will, and that's psychological. It has nothing to do with the reality of what we could do if we just committed to it.
For a few glorious years during the age of Apollo, we were all mad about the moon.
I was strolling on the moon one day.
It was fun. It was exciting.
What a ride.
It was the future. And then, all too quickly, we lost interest. We moved on. But the moon is far more important, far more useful than we ever realized. For billions of years, it's gazed down on us, shaping and changing the course of life here on Earth. Quite simply, the moon has been the making of us. Do we really need the moon? Of course we do.